Thank you, Mikola. Yes, I am also a human. And recently, I've been getting interested in digital identity. So, digital ID systems like WorldCoin are being widely deployed all over the world. So, for instance, the EU Commission is rolling out the EU Digital Identity Wallet next year. And the more I looked into these systems, the more troubled I became. The EU Digital ID Wallet, for example, has selected a design that does not afford the user any privacy. Its user actions are fully linkable, and this is what they're going to deploy in 2026 in violation of their own regulations, which specify the need for unlinkability. So my question was, how is it that the EU Commission could sleepwalk into choosing such an inadequate design? How can we prevent this? And how can we, furthermore, prevent the deployment of digital ID systems in contexts that are inappropriate, that don't meet strong authentication? And how can we prevent deploying them in contexts where they're strictly worse than existing physical forms of verification? So this talk introduces a threat modeling framework called privacy invariants, or invariant-centric threat modeling. And I propose this as one systematic way we can identify privacy violations in our protocols. So first of all, I want to introduce two related but distinct concepts, authentication and authorization. So authentication refers to proving a unique identity, like a national ID or employee ID that can map to a natural person or like just a single entity. Whereas authorization expands this access list to a set of size n. So I am one of n citizens, I am one of n employees. And of course, in cases where this set is size 1, so like the set of people who can access Mikola's bank account is Mikola, this authorization reduces the authentication. Now, it's important to distinguish between them because a digital ID affords us the ability to authenticate people, to uniquely identify them. And they are right now being deployed in contexts that do not require such strong authentication. For example, age verification. That requires only weak authorization. That requires you to prove membership in the set of people above 18. So digital ID is not appropriate for such context. It should not be naively used for such context. And this principle is called purpose limitation. It's simply limiting the amount of data that you collect, limiting what you can even do with it. So in order to reason about the requirements of these applications, and in order to identify when our solutions violate them, one useful framework I found is invariant-centric threat modeling. So if you guys are familiar with threat modeling, usually threat modeling frameworks, they approach the problem from, is like imagining possible attacks. So like enumerating all the possible adversaries and all the creative ways they could attack your system. So the main drawback of this like attack-centric frameworks is they are prone to a failure of imagination. So invariant-centric threat modeling flips this and starts with 0 assumptions about your adversaries, and then it sets out basically the invariants that you want to preserve, the guarantees that you want to provide your users. And so it's building up this series of guarantees of invariants and identifying when they're violated. So, and the Zcash wallet application uses this framework, for example. So I'm going to take us through two use cases where digital identity is being applied. And to me, these are edge cases because I think these are cases where digital ID should not be applied. So the first one is humanitarian aid distribution. Basically, in a crisis zone, you're like an organization like the Red Cross is trying to distribute aid, but make sure that, for example, nobody double claims it, that everyone who claims it is a registered legitimate recipient, and so on. And to do this, a bunch of organizations have simply created a digital ID system in the community of refugees. So, for example, the World Food Program in Yemen, Western actors in Afghanistan, they built up, in these two cases, a database of biometric data about the refugees. And in some cases, these were political opponents of the authorities of the regimes in power. And when these external actors leave, they often leave behind these banks of biometric data that would endanger the refugees. Another edge case is a very, very common age verification. So I'm going to focus in particular on physical age verification, which means whenever you present your physical ID right now. So in the pub, this on your left is a screenshot from the UK government that say like pubs, clubs, and shops will now start to accept digital IDs. And the other screenshot is from My Colorado digital ID program. They are also partnering with physical businesses, breweries. And so I'm going to argue here that digital ID is strictly worse in these cases. It should not replace physical IDs. So the first edge case is aid distribution. So this screenshot is from a research paper called Not Yet Another Digital ID System. So these researchers were working with the Red Cross, and they basically argued that a successful aid distribution system does not need yet another digital ID system. So they've set it up with these parties whereby the recipient registers into the system and then receives some credentials and is able to then use them to redeem goods at the distribution station. And another requirement of the system is that it needs to be auditable after the fact. So the auditor needs to be able to access the logs in a privacy-preserving way. So now we're going to go through the exercise of invariant-centric threat modeling. What are the privacy invariants that we want to preserve here? So firstly, the registration station, they are learning a lot of personal information about you, like your name, your household needs, etc. So they are learning all that. But what they should not learn is how you're transacting in the system after you register into it. So it's kind of like the WorldCoin apps shouldn't learn about your transactions. The registration systems should not be able to observe you making a transaction. The distribution systems should not learn anything about you beyond whether or not you're registered. So yeah, they should only be able to authorize you and not authenticate you. The auditors looking at the logs should not be able to tell whether two transactions were made by the same recipient. So they should not be able to trace a single recipient through the logs. So yeah, this is, I really like the privacy requirements, privacy invariance framework here, because then we can sort of analyze different alternatives, different solutions, according to whether or not they preserve these invariants. So a lot of 8 distribution systems still use manual pen and paper solutions. So to register people, they create a list of registered households. And they then give it to the distribution system. So after you're registered, they cannot track you anymore because you're not leaving a trace of your actions. Because the distribution stations are not communicating anymore with the registered stations. But the distribution stations do receive all your information, all your particulars, your name, and they request that data from you at the point of distribution. So for them, it is extremely clear who is receiving aid from which station. So this violates the privacy invariant that distribution stations should not learn any information, any personal information about you. And the auditors, after the fact, also get access to the logs that the distribution system used. So they learn basically the same information that the distribution stations do. Now, this is not an optimal solution, but biometrics are even worse. So in the case of biometrics, the registration station, like WorldCoin, scans, say, all your irises. And then the distribution station afterwards checks against the database whether or not your iris appears there. So I guess if you actually used WorldCoin, the distribution station could just check that you're in the set of participants. But as they're deployed in these 8 distribution systems, the distribution station literally scans your iris and asks the registration station if you're in the list. And because these transaction logs are personally identifying, once again, any auditor would be able to trace your actions. So what this research paper concluded was that digital identity is way too strong of a system for humanitarian aid distribution. And really all we need is a weak authorization that preserves certain security invariants. So all we need to do is check that you're not double claiming. All we need to do is check that you're registered. And we don't need to know any personal information about you beyond what you've given at registration. So basically they introduced a system where the registration station blindly signs tokens and distributes them to households, so that at the point of distribution, there is no way for the registration station to identify that it's your token, and there's no way for the distribution station to learn anything about your identity. And at the same time, these tokens are stateful, so they encode how many times they've been redeemed within a certain time period. And so an auditor only needs to check that each token, that the tokens add up to the total amount of aid distributed without learning any personal information. So yeah, I recommend everyone read this paper, Not Yet Another Digital ID, because it's really questioning the premise of whether digital ID is appropriate in many situations. So yeah, the other use case that I wanted to go through is physical age verification. So this is another edge case because it's replacing a physical interaction with a digital interaction, and that is strictly worse. So how it's been proposed, like the EU Digital Identity Wallet, for them, age verification is one of their main use cases. And how they propose to do it is you, the holder, you get some kind of credential, let's say a passport from your government, and you're able to make proofs about this credential and present, let's say, a proof that you're over 18 to a verifier. So this is very nice because the verifier doesn't need to phone home to the issuer to get your credential. So you can locally make a proof about your credential. Now, what are the privacy invariants that we want to preserve here? So first of all, as before, the issuer should not be able to link presentations to a holder. So by looking at transactions happening in a system, the issuer should not be able to relate two transactions to one holder. The verifier, once again, should not learn any personal information about a holder. They should only learn that she is above 18. And similarly to the issuer, the verifier should not be able to tell whether or not two presentations came from the same holder. So the solution currently proposed by the EU Digital Identity Wallet is something called SDJETs, Selective Disclosure JSON Web Tokens. And these violate the privacy invariants about linkability. So SDJETs allow issuers and verifiers to link transactions to individual holders. How it works, just really quickly, is that it takes the credential and it kind of obfuscates the plain text values by hashing them with some salt. So the issuer, instead of signing the plain text credentials, signs these salted hashes of them. And the idea is that the holder can then present, can then disclose a subset of these hashes while keeping the other ones closed. So I could choose to just open the first hash, my name, and then leave the other two as random strings. The issue with this is that the hashes themselves are unique. They are random, but they are unique. And so if I present the same hash twice, even if I don't open them, I can be linked. So this is the solution that the EU Commission settled on and will likely roll out in next year. Yeah. So most zk-ID solutions that you might be familiar with try to improve this by concealing these salted hashes as private inputs in a zk snark. So this does solve the problem. Yeah, and the project I'm working on is trying to integrate these and propose it to the EU Commission. So yeah, if once again we compare these protocols according to the privacy invariants, we'll find that, yeah, the SDJETs, they violate linkability for both issuer and verifier. They actually do preserve selective disclosure, so that's a typo there. Whereas physical ID presentations are not linkable, like the issuer has no idea who you're showing your license to. The verifier is not recording your license, and so does not have a log of credential presentations that it can link. But yeah, physical ID does not preserve the selective disclosure invariant because you are showing everything about yourself. whereas anonymous credentials, ZK preserves all these invariants. I think I'm at time now. But yeah, just to wrap up, there's this final privacy invariant that is unique to physical ID, which is repudiation. As I mentioned just now, a physical ID presentation does not create any logs, and meaning that after presenting the ID, you can plausibly deny having made that transaction. Like if I buy alcohol at the liquor store with cash, I can later just deny that I did that. Whereas, like, for example, SD jets do not allow you to do so, and anonymous credentials using ZK's narcs may or may not, depending on which fields you reveal. So that's the end of my talk. Thank you for your attention.
Questions? Oh.
Hello, thanks for this speech. I was talking to a colleague of yours, both in terms of as a human and as a cryptographer, and he's also thriving for making this EUD less a catastrophe. And he was telling me that from a code point of view, from a cryptographical point of view, like it's like just a disaster. And so I was wondering why, what do you feel is missing? Because actually I feel being a little bit close to these kind of institutions that there is not bad intentions behind this like very bad deployment or theory. I think for sure there is like lack of diversity in the team that then go to deploy these systems and work on these digital systems. But I'm wondering, like, for this friend of mine, Jaromir, you know him. It's a matter of lacking of meritocracy. And so given that I really feel that there is not bad intentions behind, like, let's build shitty systems so that we can rape all the identities, I'm wondering what is for you lacking, what's missing, and why there are not like good cryptographers working on this, and how do you feel we can manage to actually speak with these institutions and help out to build something more meaningful? Because I think that there are many good people there around, and I think personally my take on this is that don't disturb me, please. I personally feel that thanks, I got lost. I personally feel that what's missing is
I think I have a hypothesis on what's missing as well. So the EU Commission actually do have a series of requirements and guidelines that have like strong privacy requirements. For example, unlinkability. They themselves wrote it there. And so given already a list of privacy invariants, I think what was lacking was a systematic analysis of whether their solution violated or preserved these invariants. So like I think we need an easy framework that can make it very, very clear when they are in violation of agreed privacy invariants. So yeah, because there is really no way they can deny it once they're shown an analysis that's laid out so clearly. And in fact, that's what happened. They asked for cryptographers' feedback on their protocol, and this consortium of cryptographers like just ripped it to shreds. So we need like to start with these privacy invariants, and then we need a systematic way to analyze whether or not they're preserved, I think.
Thank you. Other questions?
More here.
Oh.
Can we change something? Can we complain to the commission in order to raise awareness for them to change this?
That's what I've been wondering too. So the cryptographer's feedback is public, and in response to that, they are actively looking for other solutions. So they are considering zero knowledge proofs as a solution. But I think the damage has been done in many ways. The reason I say this is that many other countries are following the EUDI. So I know, for example, the Taiwan digital ID wallet has chosen SD jets, and they're gonna have the same unlinkability problem. So the question of, like, in Taiwan, for example, there's a very strong civil society. There are these groups that make a lot of noise, that can pressure the government, that can raise awareness, that can communicate to the public. And I think that's very powerful. In fact, the first iteration of the Taiwan ZK ID was the Taiwan digital ID was so unpopular that they had to like prematurely stop it, and this is their second iteration. So I think, yeah, in countries with a strong civil society, where the government can be pressured by these groups, it is absolutely worth it to raise awareness and to advocate for privacy. Yeah.
Do you know what the name of these groups have been?
Yeah, there's like the Open Culture Foundation. There's like, well, I can tell you offline. Yeah, there's a few. Audrey Tang is an advocate for privacy in Taiwan as well. And also there, by the way, agencies that audit other audit ministries. So if we can get the auditors to change their guidelines and requests, then we force the ministries in that way to be compliant with these guidelines. Yeah.
Questions? Then I would ask this one, like you're dealing with the government officials, and as I said, you're going through the maze of bureaucracy from this scene. How the so-called Web3 builds a language and mutual understanding with like government officials, and how we should build collaboration, and where we should sort of like as a culture put hard no or hard stop, because generally speaking decentralization is about changing power dynamics also from the government.
That's a good question. Yeah, I think I was speaking with Audrey Tang a little bit. She has experience sort of playing the game. She was an activist, and then she was sort of brought into the Ministry of Digital Affairs as a reverse mentor. So it's a combination of understanding the processes of government, for example, like targeting the auditing agency, as well as educating the government officials, like, yeah, communicating like at a high level what privacy and variance you have and what technologies you have to achieve them. So my experience, I've been just trying my best to just integrate, to meet them where they are, to integrate with like their existing APIs, to demonstrate to them like how simple it is. Yeah, a lot of it is about understanding that government projects operate on a really long time scale, and they involve multiple layers of contractors and subcontractors. So I think always the principle is to keep it simple, and to remember like your objective is to get understanding from the other party.